So we left off in the last video talking about the two different properties of radicals, and now we're going to apply them. So in number 5, we're looking at example A. We're going to follow the example that is in the book and do A like the example that's in the book. So before we start on 5A, let's go ahead and look at this example in the book. The square root of 48 in the book it shows is equal to the square root of 4 times the square root of 12. You can even do this in more steps. You can say, all right, I know that 48 breaks down into 4 times 12. And then you can go from there to over here and say, all right, the square root of 4 times the square root of 12 is the same as the square root of 48. From here, you can go ahead and you can ask yourself, what number multiplied by what number is equal to the number underneath the square root? And that answer is 2. 2 times 2 is equal to 4. So we simplify that portion. From here, the book shows, all right, we have 2 times the square root of 12. We can continue to simplify. The square root of 12 is equal to the square root of 3 times 4. And then we can break that down into the square root of 3 times the square root of 4. Once again, the square root of 4 is equal to 2. So instead of having just one 2 up front, now it's also going to be multiplied by another 2. And then we carry down the square root of 3. 2 times 2 is equal to 4. So the final result is going to be 4 times the square root of 3. From here, you can go ahead and multiply. You can multiply 4 by the square root of 3, and you'll get the result of 6.9282, etc. And then you can take the square root of 48, and you will see that you get the exact same number. So you can check your work when you're finished to make sure that you actually simplified it correctly as you start using these properties and are practicing this model. All right, so 5A. They've already broken this down into 2 factors, and now we're going to apply the property that you just learned. We're going to break this down into the square root of 9 multiplied by the square root of 5. The square root of 9 is equal to 3, and we multiply that by the square root of 5. Now, 5 has factors of 1 and 5. 5 is a prime number, so it's only divisible by 1 in itself. And there's nothing we can do with the square root of 5 or the square root of 1 that's not going to help us because 5 is not a perfect square. So our final answer is 3 square root of 5. And I want you to go ahead and put into your calculator the square root of 9 times 5. And then I want you to put into your calculator 3 times the square root of 5. And both times you'll get 6.7082, etc. All right, 5B, the square root of 18 times the square root of 8. In this example, what I'm going to do is I'm going to use the rule backwards. So instead of splitting it up into more factors, I'm going to put all of the factors underneath one square root. So you can go from here where you have multiple radicals over to one radical, or you can go the opposite way, whichever is most useful in the situation. So now I'm going to start breaking down 18 and 8 into their factors. We're going to do a prime factorization of each. So 18 can be broken down into 9 times 2. And while I'm doing the prime factorization, I'm going to stop right here because I noticed something. If you notice something right away that's useful, you don't have to do the complete prime factorization. I noticed that 8 times 2 is going to give me 16. 9 and 16 are both perfect squares, so they're really nice to work with. From here, I'm going to split this back into 2 radicals. And then I take the square root of 9, and I get, well, 3 or negative 3, but I'm just going to write it as 3. And then you get the square root of 16 to be 4. 3 times 4, you get 12. Now what I want you to do is I want you to take the square root of 18, and I want you to multiply it by the square root of 8, and you should get a result of 12. And then you can also take the square root of 9 and multiply it by the square root of 16. You get the same thing. Another way we could have looked at this is we could have right away just multiplied 18 times 8, and we would have gotten 144, which you should recognize as a perfect square. 5C. In this case, they give it to you where it's not broken down into factors. So let's go ahead and factor it. So now we break this down into 9 times 5, and we're going to split this up into two different radicals. The square root of 9 times the square root of 5. The square root of 9 is 3, or negative 3. We're going to just keep it as a positive. So you get as your answer, you get 3 square root of 5 as your final result. Once again, compare the two. The square root of 45 gives you 6.708, etc. And 3 times the square root of 5 is also equal to that same number. All right, 5D, again, follow the same rule. We have the square root of 4 times the square root of 9. The square root of 4 is equal to 2. The square root of 9 is equal to 3, and we get 6 as our result. Once again, don't forget that the square root of 4 could be 2 or negative 2. This could be 3 or negative 3, so the result could be either 6 or it could be a negative 6 as well, depending on what you choose here, whether it's a positive or a negative. All right, E, I'm going to break this up into the square root of 4 times the square root of 1/9. The square root of 4 is equal to 2. And then we're going to apply the second property that you learned where we can split up the radical when we're dividing. So we have the square root of 1 over the square root of 9, and that's all multiplied by 2. The square root of 1 is equal to 1. 1 times 1 is equal to 1. And the square root of 9 is equal to 3. So we have 2 times 2 times 1/3, which is equal to 2/3. And again, you can check your work by just going ahead and putting into your calculator the square root of 4 times 1/9. And then you can also just check that against 2 divided by 3, which will give you 0.6 repeating. 5F, we're using our second property. We split this up into the square root of 9 divided by the square root of 4. The square root of 9 is equal to 3 or negative 3. The square root of 4 is equal to 2 or negative 2, so we get 3/2. And again, you can check it using your calculator. The square root of 12, you can break up into the square root of 3 times 4. And then you can split it up into two separate radicals, the square root of 3 times the square root of 4. The square root of 4 is equal to 2, so we're left with 2 times the square root of 3. 5H, the square root of 96. Again, you want to factor it. So we can take 96 and we can first just divide it by 12. From there, we can split it up even further. So we can split 12 up into 3 times 4. We can split up 8 into 4 times 2. Whenever you have a pair, you have a perfect square. So whenever you have a pair underneath the radical, you have a perfect square. 4 times 4 is equal to 16. And then I can split this up into 3 radicals. So I can split it up into the square root of 3 times the square root of 16 multiplied by the square root of 2. The square root of 16 is equal to 4. 3 and 2 are both prime numbers. So they are not perfect squares. Can't do anything with them. I'm going to go ahead and put them under the same radical. 6 is not going to be a perfect square, so you can't take the square root of that. It's going to be an irrational number, so your final answer is 4 square root of 6. The other thing you can do is you can look at the prime factors, and if you don't have a pair, then you don't have a perfect square. So that's when you know that what's underneath the radical is as simple as possible. And this is as simple as it gets. Okay, in number 6, what we're trying to look at is addition. And this also is going to hold true for subtraction. This property that you learned where you can split up the radicals only works when you're dealing with multiplication and division. Just like when we're talking about our exponent rules only applied when we were dealing with multiplication and division. It does not apply to addition or subtraction. So what the book wants us to do is it wants us to look at some different numbers and some different examples and prove that it's not going to work for addition. So let's just put some random numbers in here. Let's try 5 for A, and let's just make it up. Let's make B 3. So we're going to put in, under our square root, we're going to put in 5 plus 3. So that's the square root of 8. And we're going to prove that this is not equal to the square root of 5 plus the square root of 3. So I want you to go ahead and find the square root of 8. The square root of 8 is equal to 2.8284, etc. Now, the square root of 5 is equal to 2.23606, etc. The square root of 3 is equal to 1.73205, etc. And I'm going to add those two. And we get 3.968, etc. And I didn't put in all of the decimals, so it's all the decimal values, so it's not going to be perfect. But you can see that those two values are clearly not equivalent, so it's not going to work. Let's do one more example to prove that it's going to work, not going to work, and then we're going to move on. So let's use, let's say A is 10, and let's say B is 50 this time. So we have the square root of 10 plus 50, and we're going to show that it is not equal to the square root of 10 plus the square root of 50. So the square root of 10 plus 50 is also equal to the square root of 60. So we're going to take the square root of 60, and we get 7.7459, etc. And the square root of 10 is equal to 3.16, etc. The square root of 50 is equal to, oh, didn't mean to write that, is equal to 7.071, etc. We're going to add those two values together, and we get approximately 10.2. And you can see that those are not equivalent. So again, these properties only work when you're multiplying and dividing. It does not work when you are adding or subtracting. So it's really important to remember that. In summary, these are the things that we talked about. We talked about the square root of n is equal to n to the power of 1/2. The square root symbol is the same as taking something to the power of 1/2. We also looked at the property where you can take the square root of a times b and split it up into the square root of a times the square root of b. Remember, it only works for multiplication and division. So we can split up the square root of a divided by b into the square root of a divided by the square root of b. This does not work for addition or subtraction. So you can't use the properties here for addition and subtraction. And we will continue working on these problems when we look at the Check Your Understanding in the next video.